Now that we know that most atoms have an incomplete octet in their valence shell, let's work on understanding how they can achieve that octet. And they can do that by forming bonds. They can either transfer electrons, give and take, or they can share electrons. So the type of bonding that we've encountered so far has been ionic bonding. And that involves the transfer of electrons. You have a positive cation and a negative anion. Metals have so few electrons, this is why they always form positive ions. They have so few electrons in their valence shell that the easiest way for them to achieve an octet is to lose that electron and downgrade. Just as we mentioned here in the last video, that one valence electron can go, and then it downgrades to this valence shell now, and it's completely full, it's completely stable. So it's way easier for them to give up one electron or two electrons than it is for them to take 6 or 7. Okay, nonmetals are the opposite. They have enough valence electrons that it's much easier for them to take electrons. That's why the nonmetals are always the negative ions. So chlorine here, you can see it only has those 7. The choice is to either gain 1 or give up 7. It's way easier for it to gain 1. Which is why sodium and chloride tend to go together really well and form our table salt that we're used to. This sodium just gives up 1 electron, chlorine takes it, and they're both completely stable. The type of bonding that we're concerned with today, however, is covalent bonding. And that is the sharing of electrons. We're only dealing with nonmetals. So those have valence shells that are full enough that they don't want to give any electrons, they can only take. So they have to figure out a way to bond with each other while thinking that they're both taking electrons. Let's use an analogy of people getting married. Okay, let's just do this off in the margin here. Right, we've got our 2 people here. And let's say, so they're single now. Although not single, but they're not married yet. They haven't moved in yet. And so each one of them pays rent, let's say it's $1,000 a month. Okay, they're each paying $1,000 a month. Now they move in together. They move in together, not only do that, but they upgrade. They move into a nicer apartment or house. And they pay $1,400 a month. So they each saved $300 a month. They're now each only contributing $700 a month. So they have an extra $300 in their pocket. Did anyone actually get a raise and start making more money? No, they didn't. But each one has more money anyway. Each has $300 more. And as we know, up to a point, of course, more money equals more stability. And so atoms are the same way. Nobody's actually gaining an electron. They're sharing them, but that gives them the illusion of having more electrons. Okay, so if you look at this picture, we've got our 2 chlorine atoms with their 7 valence electrons each, and then these 2 are shared. So from this atom's perspective, these electrons belong to them. But from this atom's perspective, these electrons belong to them. It's like if you have 2 trees right on the property line, directly on the property line. Each neighbor effectively has 2 trees. Okay, each neighbor gets to sit in the shade of 2 trees. Each neighbor gets to eat the fruit of 2 trees. However, it's only 2 trees between them. Right, so the electrons here are the bonding electrons. These other electrons in the valence shell, the ones that are non-bonding, are called lone pairs. You have your bonding pair and your lone pairs.